Hey guys, welcome back. A quick update on the Philco 41280. Last video I showed some testing on the Field Coil, and even though I got some decent results, there was definitely a problem with the Field Coil itself. And here's what's left of it. I disassembled it, and of course it didn't look this way till I got a hold of it. But quite a mess. There was an open winding somewhere. I actually removed the paper and tape and went back in about 2 layers and still had very intermittent DC resistance. So looks like the problem was buried more toward the core of the Field Coil, which is not uncommon. Anyway, probably best served if you look at this basket on this 12-inch speaker. You can see all the corrosion and rust on it. The spider itself here in the center was in such bad shape that I ended up it just fell apart. Basically, it was just dry rotted. So I'm not sure, even if we would have got this thing back together with the radio turned up, what kind of problems we would have had. The spider was already fractured in places. But we'll de-rust this, and then you can see I did just a little bit of damage trying to get the supporting frame around the Field Coil out. This particular Field Coil had these small pieces here attached, and I actually just cut them out. And wasn't the easiest task, since I didn't have bolts going down through that you see on a lot of the Field Coils that just allow you to easily remove the center pole piece. And in this case, you can see I actually had to cut this, and I've since gone back and filed the edges. I still need to flatten this up just a little bit more, and then we'll put everything back together, or that will be the attempt. Anyway, let me show you what we've got. This particular basket here, again, that we'll work with, it uses a 3-inch depth speaker comb, so I've got that on order. The dust cap I'll create myself out of some felt. It's about 1.1 inches or greater. We'll stick a new 4-piece gasket on it. That's pretty self-explanatory. Again, the speaker being 12 inches, it's roughly 11.8 inches to the edge. And then I went on and took time to, and I do this for most of my radio restorations, just in case I have to come back and recreate a part. But this is the Field Coil support frame, kind of a side view, along with that center pole piece here. Again, this is a iron material, probably low carbon, highly magnetic, and you can see here I've got a group of magnets, and it makes a very nice electromagnetic field. Actually, I wrapped a coil around it and magnetized it so it doesn't hold its memory well, which is good. Again, this piece here goes through the the top side of the, I can actually demonstrate this, the top side here, and I'll knock it back through. And then the new coil that I wind on my new coil winder that I've had a chance to build will kind of propagate through this area here. So I've got those measurements here on an additional page. I think it's around 1.5 inches or so will be the width of the new Field Coil. But anyway, I will be able to leverage that same center pole piece, which is really good. I was looking at possibly even using a piece of 1-inch carbon steel, but that'll work great, being able to reuse that. And then for the base underneath, I'll remount the speaker in the opposite plane. I'll fill these holes in here and clean this up, and then we'll apply some paint over some epoxy, and then there'll be a new base here. You'll get a lot of magnetic flux from the edges, so in this case, even though I had 1/4 inch steel on the bottom plate, I'm going to go with a spider that's not flat, that has about another 1/8 of an inch, so I'll make everything up and should have my distance correct from the spider or voice coil back to the center pole piece. But this is just kind of a mock-up here of a piece of aluminum that I'll use just on the bottom section. It'll be cut in this area. I'll drill a couple holes and then we'll reattach this, and I'll leave some wiggle room so I can center this in the middle of the speaker best I can. So I think that will serve me well. I'll get that out of the way. One thing interesting too about this particular speaker, I wanted to point out, it has a humbucking coil, and it needs to be, what I've read, and I've never really done a lot of research, and again, I'm more of a techie, not an engineer, so those out there that know more chime in, but it actually just helps cancel out hum, 120 hertz hum, from the Field Coil. So in this case, this particular humbucking coil, and I've got it documented, I think it reads around 4 ohms or so, and the wires are just, I'm not going to take it apart because I don't want to damage it or just, you know, running around this circle. It's about probably a 32nd of an inch thick or so, maybe edging toward a 1/16 of an inch. But this needs to be in phase, is my understanding, with the voice coil. And in a future video, I'll show you how to do that, just to make sure the voice coil and the humbucking coil are actually, the polarity's the same. And if not, once I get this thing back together, it's just a matter of desoldering the connection points. But we'll dress up some new leads here. The voice coil itself is in good shape, so best I can tell, it ohms out just fine, so I'll be able to reuse it. It does have a little bit of a rough edge right in this area. It seems like that center pole piece catches on just a bit, so when I remove the rest of the speaker cone here and dress up my new leads and get this removed, I'll take a closer look at it just to make sure it's definitely usable, but it should be fine. It's still got its great shape, and you can see here again how it works. The center pole piece goes in here. It looks like, based on what I can tell in the design itself, the center pole piece max went into the voice coil about this far, and then of course, as the current consumption changes, the voice coil would oscillate north or south on the pole piece. So let's see, that's about it for that. Anyway, just some more documentation here I was showing. I've got the top-down view for the center pole piece. Again, I've got all the dimensions here for the center pole piece, diameter, everything, the framing around the piece, the humbucking coil. Again, I've got it noted as well. And same thing again for the field coil that I'll be building. I'll go back and make it the same size as the field coil that was in the radio. And I've got the measurements here. This is a side view here, the flange or hub. And again, I'll create a new spindle piece myself. You guys have seen me do that, I think, before, which I'll show on the video a little bit later on. But that's kind of where I'm at right now. Again, I've got my speaker plug, rear view connection points, you know, the spider requirements. Again, all this stuff's on order. And so up next, oh, let me just show you one other thing too, just for giggles. In a spreadsheet, this may not be showing up well. I'll try to get a little bit closer to the camera here where it does show. I created like a little coil winder calculator sheet, and again, this will not be perfect for sure. And the reason why, what I did was just take the nominal depth of the or the diameter of the wire, and knowing what the max wire diameter is and the spindle length, in inches. If I were able to actually wrap a new field coil perfectly with one layer up against the next layer across the coil, you can see for this particular design where I have a spindle length of 1.5 inches, I roughly should have 294 turns of wire. So again, I've got a digital counter on the coil winder, and you can see the area is shaded in yellow. That's where I'll look to make my first measurement, somewhere around that point when we get around 26 total or 27 total wraps, and my counter should increment just under 8,000. And you can see the spindle diameter changes as you go. So again, this is just to be a ballpark. We'll use DC resistance. You can see the total resistance column over just a little bit highlighted in yellow at the top. I'll use that as a reference, and we'll make some measurements when we get close to this point and just look for around 1100 ohms of DC resistance. I'll go back with 36 gauge wire. I mic'd out the wire that was in there, and it looks like it's 35 to 36. I think the 36 will serve me well. So I'll end up somewhere probably between 2600 and 2700 feet of wire according to these calculations. Again, I'm using the nominal DC resistance per foot, and that may be north or south of that number, so we'll adjust the design. Anyway, the field coil is not critical. I could be off 20%. I think the radio would work just fine, but I'll try to make it as close to the OEM design as possible. Anyway, folks, that's all I've got for today. Stay tuned. I'll show some future videos on the coil winder with the digital readout, and then I've got to get, again, this basket derusted, this other piece here for the coil, clean these edges up and get the rust off of these, and then put some paint on them if I get a warm enough day. It's possible I won't be able to spray any paint anytime soon, just due to the temperatures here. So anyway, until then, take care. Thanks for viewing.